Well, welcome everyone. Good evening. My name is Eric SB. I'm the Recruitment and Student Services Manager here at CMU Online. Really excited for you all to be joining us tonight. We have an online student spotlight information session for our AI engineering for digital twins and analytics, which is also an online graduate certificate program. I know that some of you might have already been talking to us about the program. Some of you might have even applied already. But overall, we're really excited to bring Damon and Shane here tonight to shed some light on not only just how the courses work, the program works, but also perspective of being a student in the program. So we're really excited to share that information with you tonight. And with that said, let's get started. And before we jump in to the digital twin certificate, I did want to note for some of you that might not be familiar with CMU Online itself, we are a suite of graduate level certificate programs all online. So you'll see digital twins is in this list here. We have subjects such as foundations of data science, generative AI, managing AI systems, 3D bioprinting and biofabrication, which is really cool. We're right now it's at 7 different programs. We're looking to grow that in the coming years, and we're very excited about that. And really, what sets us apart, as some of you may know, the certificate space right now in academia is very competitive. And we really find ourselves to be in a unique space when it comes to our graduate certificates. Some of the big and key features that we are seeing that a lot of our students are appreciating is one, we have weekly live class sessions. So even though this is an online program, you're still going to get that live interaction piece on a weekly basis with the CMU faculty, instructors, etc., as well as your fellow classmates. So our students that are taking this program are really appreciative of that. And to the second point, which is below that little box, you'll see CMU faculty. This is something that's really unique. Students love that they're still being taught by CMU faculty here. Some of you may already be familiar with Carnegie Mellon. Great brand, world-class faculty. So it's nice that you're able to get access to that faculty from the comfort of your own home, which is a huge advantage. And many of you, if you've been working with us, we understand this. Many of you are working professionals. Really the graduate certificate was designed for full-time working professionals. That way you don't have to drop your job, other family commitments or social commitments to be able to take this program. So it's been a huge advantage for our students. And last but not least, graduate level credit bearing coursework. Some of our prospective students overlook this, but it's nice to know that these are full-fledged classes that you would be taking here at CMU if you're on campus. So they are fully credit bearing. Whenever you complete the program, you're going to get an official transcript with grades, just as you would get here on campus if you took one of our programs. So that's a huge draw for students, not just to have that credential, but if you're looking to take that into maybe a degree path, you have these credits in your back pocket. And with that, I'd like to introduce Damon, who's helping instruct the program. So Damon, if you'd like to go ahead, introduce yourself, tell us a little bit about, your experience so far with this program.
Yeah, thank you, Eric. My name is Damon Weiss. I'm the professor of both the Principles of Digital Twins course being offered as the first half of the certificate program, and the AI Digital Twins and AI for Predictive Analytics course, which is the second half of the certificate course. As kind of the slide indicates, I've got about 28 years of civil engineering experience, which includes a lot of digital modeling, urban systems, real-time data systems, sensors, machine learning, artificial intelligence. I've been kind of broadly exposed to all of those things, and actually have my own company, Ethos Collaborative, that kind of specializes in sustainable urban design here in Pittsburgh. What slide doesn't say is that I'm also a CMU graduate. I graduated from this same department back in 2008 with a degree in advanced infrastructure systems, which is essentially a predecessor to kind of all of this digital twin stuff that we kind of worked with. So I've been in this space for a long time. It's a lot of machine learning, databases, sensors, and how they intersect with the built environment and infrastructure world. So it's been a fabulous, experience so far.
Excellent. Thanks, Damon. That's great. Appreciate you introducing yourself. And I would like to, with this slide in particular, this is just a program overview. I would love to hear your perspective on, when you're working with your students in the program, who are you seeing that this is really benefiting? And what are some of the key things that students are taking away that you're teaching?
So a lot of the students that we have are working professionals, but we also have folks who are just kind of really, really interested and engaged in the idea of merging technology with engineering and infrastructure and just working with digital twins overall. So we've been really blessed to have, just a really engaged set of folks. And I think the things that they're taking out of it are not only kind of what a digital twin is, but how all of the pieces fit together between the data culture, building the data culture in your organization, to the technical aspects, to kind of the analytics and simulations that go into kind of making a digital twin as realistic to the real world as possible.
That's great. Yeah, thanks for shedding light on that. I mean, the students that my team's been working with that are interested in this program, it's a very niche subject, but it's a very potent subject that they're looking to gain some more knowledge on. So that's big. I appreciate you sharing that. All right, excellent. Um, And within the program itself, there are two courses. So if you haven't seen this yet, the two courses that make up this certificate are Principles of Digital Twins. That's the first course that you take. And then there's Digital Twins and AI for Predictive Analytics. Damon, I'm not sure if you want to shed any more light on these two courses, maybe the differences between the two.
Yeah, absolutely. So these are kind of two halves of the same digital twin coin in many ways. The principles of digital twin really kind of sets the theoretical foundations for all of it. It kind of demonstrates all of the moving pieces of a digital twin from, kind of the physical attributes of the system to how you sense the data, that is coming out of that system, to how you might analyze it and, work with it in kind of real time all the way to kind of the visual representation of it. And so it's really largely about how to design these systems, how to effectively manage them, the ethics behind them, and all of the different pieces that are needed to kind of put together on it. The digital twin and AI for predictive analysis really takes more of a deep dive into kind of the simulation side of it. There are aspects, it takes you kind of all the way through the analytical process from I have a physical system that I'm trying to model to here are all the different ways I can, figure out the uncertainty, figure out the simulations, the physics that go with it, and then kind of employing it so that you have sort of a dynamical system that you're able to kind of, not only predict, but simulate scenarios going forward that then feed into the digital twin system as a whole. So they're very much a lot more analytics and rigor in the second course, but both together you get all the tools that you need to kind of build a digital twin in real life.
That's excellent. Thanks for sharing that. Yeah, I think,
Yeah.
when you look at the space too, it's like you almost all the availability of certificates, there's not this one-two punch. You either like get the straight up foundations that you're not taking away much, or you have to really delve into the advanced courses without having that predecessor, and it's really hard to gain something from that. So I really appreciate you describing how, step one to step two, and then you're getting the complete picture. That's great. Excellent. All right, Shane, I know we've been hanging out here, haven't introduced you formally yet. Thanks for joining us. Do you want to give us just a little bit of your background? What really brought you to the program, and that would be an excellent starting point.
Yeah, thanks, Eric. Thanks for the introduction. My name's Shane Michael, and I graduated from CMU with a master's degree a few years before Damon did. I've been 1998 was whenever I graduated with a master's in civil engineering. I've been doing civil engineering probably for the last 35 years. In different places. I started out working in New Jersey and and a lot of it's been like in the traditional civil engineering side of things. There's the transportation side, the sanitary sewer, stormwater, water pollution, water uh, supply side of things. So I did a lot of that work in New Jersey. I also worked out in California. And that was right after I graduated from CMU, and CMU has a big research side to it. So I got interested in doing research. And so I worked in an air pollution lab out in California doing air pollution research to help, settle the smog issue that they have out there. Um, and then I also worked with private industry out in California and also with the DoD. So kind of I guess I'm getting at is kind of a broad experience of things within the civil engineering world, both, all the different aspects of it and the private side, public side. I think I developed a broad sense of the civil engineering world, and through all that in different parts of the country, I got an understanding of what it takes to do civil engineering and how important it is to be able to model a lot of these functions in civil engineering, in a computer, either through the AutoCAD systems, the Civil 3D or maybe even Revit, but then being able to do a lot of the predictive analytics to help say the public side and the private side out to be able to plan their resources efficiently. So after seeing it in other industries like the aerospace industry, I worked out in California. I saw a lot of the digital twin side. And same way in some of the other areas that I've worked out in the mechanical side of it, I've seen where the digital twins, or even like Damon was saying, some of the precursors maybe to the digital twin side of it, how beneficial they were in those communities. So I kind of like to see that same thing happen in the civil engineering community.
That's great. Thanks for sharing that. It seemed, I mean, talk about like you said, just a broad area of expertise when it comes to civil engineering. That's fantastic. I appreciate you sharing that. Um,
Yeah,
now that we're all
problem.
introduced, let's jump into some questions. So we're going to have a mixture of questions, both for Shane and Damon, just so you can gain the student's perspective as well. Because many of you you're applying, you're looking forward to potentially taking the program. So what is that perspective like? And the first question we wanted to ask you, Shane, is how did the program meet or differ from some of your expectations?
Well, I tell you, one of the things that's interesting is when you're working in the, like, say, out in the real world, and not in the academic world, there is a little bit of a difference there. So it didn't take a lot, but I mean, it took a little bit of getting used to being in the academic side of things after being out after, continuing to be out in the wilds of civil engineering. Yes, I got the master's in civil engineering at Carnegie Mellon. And it's definitely a rigorous program, I have to tell you. I mean, I think one of the gifts I got when I joined this program was a coffee mug, and I thought that was so appropriate because you definitely you gotta stay awake, throughout for there's sleep is a secondary thing a lot of times in these programs, and so that kind of met my expectations because it's such a good program to understand the foundations and the fundamentals of things, which, I think is I mean, really, no matter what you do, but I mean, I think it's very important to get a good, broad foundation, fundamental understanding of the program. And that's how it kind of met my expectations was from the previous experience I had with CMU and what it is today. Um, I don't know. I guess I was a little biased coming in, so it didn't really differ anything from my expectations. I kind of knew there was going to be a rigorous program going in, and it continues to be that. And quite honestly, it's, if it's a challenge, I think that's great. I mean, it's good to be able to broaden your horizons on things.
Yeah, that's great. And we hear that my team works with everybody to apply to the program, and we see that in the essays. It goes back to the CMU recognition. It's, yes, it's online. That means there's going to be some flexibility there, but is it going to make it easier? No. There's still that area of discipline and being able to balance work with this, and it is going to be a challenge. But again, the harder the challenge, the better the reward. So that's great. All right, let's go to the next question. Oh, this one. I mean, we got Damon here, so
I'll try to be nice.
uh, yeah,
I just plugged my ears for
yeah,
all.
yeah. Damon's just gonna pop out of the room for a minute. Uh, yeah,
Well,
Shane,
my experience with the
yeah,
instructors and, I mean, all throughout CMU, I really like all the professors I've had, with Damon and Mario and Pingbo. Those are the current professors for this class. I mean, I think they're great. I mean, they're very personable. I mean, you can talk to them. They're not like an academic, you know, so much trying to talk to them. They're more down to earth, you know, and they can, I don't know, speak the layman's language, I guess, as well as speak the technical, mathematical type of language, and be able to explain those technical and mathematical functions and programs in a way that it's understandable. You know, not you know, it's not all just equations. You know, it's not all just theorems or proofs. You know, it's understanding how what we're doing is being applied into the real world. And I think the CMU professor, and it was the same experience I had in the past, that they're all grounded in the real world in some sense, and they know the material so well and understand it so good that they can then talk to people that maybe don't understand it quite as well in a manner that they can understand it. The course material, I mean, it's challenging to tell you the truth. I mean, and that for me, that's what I like, that it's a challenge because it really pushes the boundaries of your understanding on things. It helps to have a good understanding of at least some of the basic functions of like math and the systems that we're doing. And I think the course material is set up in a way that it if you understand the basics of it, you know, you can do well. But there's also that more detailed type of portion of it that helps challenge you in a way to understand the program and what the processes are.
Yeah, that's great. Thanks for sharing that. And yeah, Damon, I'd love to flip the script on you. What's it been like teaching?
Well, let me build upon this a little bit. I think Shane made some really good observations, but he also dropped a couple names of folks who are not here, and I think that's worth explaining here. The Digital Twin Certificate Program is actually set up as a asynchronous portion of classroom time and a synchronous portion of classroom time. I essentially teach the in-class synchronous portion, and there are other professors at the university who specialize in kind of some of the simulation and analytics and everything, who are actually teaching the asynchronous portion. And so what you're actually getting there is kind of two perspectives in many instances. You're getting kind of the pre-prepared lectures, and then you're getting me kind of giving kind of the current day relevance of it, and kind of being able to work with the students to better understand, deep dive into it. And they're all professors who are currently at the university, so they come in and chat as far as join the lecture occasionally um, you know to add to the conversation. So you're getting kind of a nice perspective from multiple faculty in the course.
That's great. Yeah, thanks for sharing that. And I don't think you see that in a lot of online programs, getting multiple perspectives while you're going through coursework. It's fantastic to hear that. So thanks for sharing that.
Yeah.
Yeah, this is a good question. Yeah, Shane, if you want to, highlight, have you been able to apply anything that you've learned from this program so far? I know that you're still, you know, it's still fresh. You're still going through it.
Yeah, yeah, it is fresh, and that's part of. I think it's not fresh to me too, but I think the civil engineering world right now it's kind of fresh too, and I think that we're all trying to sort out. I think maybe Damon and some of these other guys might have a little bit more experience in the application than I do, but that as a practicing civil engineer, I've been able to find instances where I've been able to apply just from the past spring, taking the class and put it into the work that I'm doing. For example, the one of the big things is digital twins has that physical aspect to it, and the thought is taking the physical into the digital side. And one of the things is trying to model that actual physical world in the digital. And so one of the ways we've been able to do that is through using these laser scanners. And you can go out and take a laser scan of, say, a bridge, for example, and then that'll give you a digital representation through these point clouds, a whole series of points that represent what that bridge is. Now, then you can take that and put it into a digital format. So that'll give me an actual what that bridge is not necessarily what it looked like as a designed bridge, but as an actually physically built bridge, say as an example, and they have that as a model in the computer now that I can then manipulate to be able to maybe do a bridge inspection on or put a sensor on to understand how that bridge is reacting to in a world type of sense. And so that's one aspect where we've been able to start doing those types of things with laser scanners. We've also we've been able to put maybe sensors in different areas to and gather that information in to get an understanding of things that maybe we can't see or don't see or have a difficult time quantifying whenever we're out, say, looking at it or just writing down pencil and paper, even taking pictures. So those are the types of things that I think are beneficial to help civil engineers understand what's happening dynamically out in the world, as opposed to just a snapshot, say, whenever you go out there once and take a look at something. And I really think, I mean, comparative to some of the other industries, I think that there's a lot of applications available or potentially available in the civil engineering world to be able to use the digital twins and the AI predictive analytics to help, like I was saying before, like help people decide and how they're going to put their resources to things, and especially in the civil engineering world, there's a lot of say public dollars that go towards things. So there really got to be an efficiency involved in that to be able to use a lot of the information that we have.
That's great. Thanks for sharing that, Shane. David, I don't know if you want to add anything else to that or
I will actually.
yeah.
Yeah, I think one of the most exciting things about this course to me, and what we try to kind of convey to all of the students, is that there is a very wide range of tools and technologies that are kind of converging the last 5 years, 10 years around digital twins. I mean, I think if you were to go back 15, 20 years, you didn't even have that name to work with. Now you have, um, real-time simulation engine, we've got generative AI. We have all kinds of machine learning, cloud computing, 3D scanners in your phone. My phone can take basically LiDAR of anything, and we can do intensive modeling and intensive analytics. And all of these technologies kind of have converged on the digital twin space. And so to me, when you start thinking about how engineers and other practitioners are applying these ideas, they first have to know that the tools exist. They first have to know how to put them together, and then it's just basically an imaginative, creative process. And that's kind of the part that I really like to enjoy teaching, essentially.
Yeah, and if I don't mind, Eric, if I could, I mean, knowing those tools exist, I mean, that to me is a big part of it because being out in the civil engineering world, I always, hear these things that are going on, but it's nice to be able to sit down in a course like this and really get your hands on, feet wet, so to say, in a program that has all those tools and are able to apply and show us how to apply all these tools in the civil engineering world.
Yeah, that's fantastic. Thank you both for sharing that. I think it's across all industries where it's just a constant feed in your face of all these solutions, whether it's software or a service.
Yes.
And it's nice to debunk some of this stuff to realize what you actually need. So that's a really great take, Shane. All right, a few more questions left, and then we'll get into some Q&A. This is a good one. Shane, what do you wish you would have known before starting classes? It's always a good question.
Uh, how much caffeine is in coffee?
Get a bigger cup of
Get a
coffee.
bigger
Yeah,
cup.
yeah.
What do I wish I'd known before I started my classes? Well, one of the big things I believe in these classes and probably comes along as a complementary type of skill that you'll have is the time management side of it. Because me, I know a lot of other folks are the same way that I work during the day, I go, throughout the day and like a 9 to 5 type of thing. And so it's hard to do these classes during the day. And so that's what's nice about having these online classes that are in the evenings. I believe the class starts at 8 o'clock in the evenings, which is perfect. So that helps with the time management side of it, where I have time to do my work during the day for in the civil engineering world, and then be able to take the class and then the different assignments and lessons that we have, be able to take the time and understand in my own manner how to proceed through those classes. So the time management is one of the big things of it, and how to and trying to, because we all have our lives that we're leaving, and how to juggle all those different aspects of it, and to be able to get a good benefit out of this class. Uh, that's probably the big thing. I mean, for me, going to CMU, I already had some of the ideas going into it. I mean, I knew it was going to be a rigorous course. I knew it was going to be, heavily involved in math, programming. Those are some of the other things. In the CMU course they're definitely a challenging course, but those are again some of the things I knew. I mean, it's been 20 some years, but I think CMU still has that same um, challenge to it for these classes, and those are some of the things that I might have known going in, but they still exist there today.
Yeah, that's great. Thanks for sharing that, Shane. And the next slide, we flipped the script. So, Damon, we'd love to hear from you. What are some things? We have a lot of folks here that are planning on applying, getting ready for classes. What are some of the things that would be beneficial for students to know before joining the program?
I mean, there are certain technical skills. There are certainly, there's some coding, some Python related coding in the second class in particular. The first one is pretty easy along those lines. It's a lot more theory and fundamentals and foundations. I would say the biggest thing that would be beneficial for students to come into class with is sort of a systems perspective. We all have sort of our siloed past life experiences and such, and all of those things come in to inform the larger class discussion. But there's kind of a component of this digital twin that's on the back end data side. There's a component on the governance side. There's a component on the front end visualization side. And so just kind of getting a broad appreciation for all of the different tools that might be out there that are kind of adjacent to digital twins will help you put together all of those different pieces over time.
That's great. Thanks for sharing that, Damon. That's huge.
Yeah.
All right. We've come to the final slide, and as promised, we will round out this session with some Q&A. So I see there's questions already going on in the chat, which is fantastic. If you all haven't connected with Marlene, who I work with, she is our program specialist. She will be reaching out to all of you after this session with a link to the recording, just so you all have this at your disposal. But Marlene's fantastic. So if you want to dive into more of the depths of the program, figuring out if this is going to be a great fit for you, and if you want to apply, we help you with that entire process. So Marlene's going to be your go-to, and she's fantastic. Um, Great. So we're gonna take the slides away just so our faces are a little bit bigger. But we had some great questions come through already. So Shane and Damon, if you would like to help, the first question, we actually got a lot of questions too before this session, just about the software piece. So when it comes to the digital twin stuff, when it comes to the data analysis, running simulations, what are the soft pieces of software that is being used in the program?
Yeah, so I mean, there is certainly a lot of different software that we are kind of introducing and working through. Some of it is related to reality capture and the process of collecting point clouds. We've been using Autodesk Recap as well as a open source program called Cloud Compare, just to help students kind of get a better understanding of how to manipulate a point cloud, what it is, what it isn't, and how to kind of convert that into a more intensive model. We use Autodesk Revit to help translate that point cloud into something more intensive. We have been introducing basically Python scripts and Python digital twin examples to work with. And we're starting to introduce things like NVIDIA Omniverse into the curriculum, because that is kind of getting a bigger place within the digital twin space. We're also looking at other software. Bentley makes a twin builder. So there's between the two classes, there's going to be sort of a broad selection of different digital twin software. We introduce Amazon Web Services and some of the cloud-related resources that are used kind of in the middleware piece of that puzzle. And so we try not to be too we try to be as tool agnostic as possible in it, because I think it's the fundamentals of digital twins that kind of transcend the tools themselves. But you do get a good introduction overall to some of the tools.
Yeah, and sorry if I may add. I mean, being as a student, a lot of the programs that Damon mentioned, I didn't have a copy or didn't have access to them, and I mean, and some of them are awfully expensive, to go out and get. But being a student at CMU, I have at least a student access into a lot of those programs, and so while I'm a student, at least I'll have most, almost if not all the ones that Damon mentioned, I got access to them. And that as well as any research papers that are out there. I mean, I get access to the different online research programs that are there too, which is really beneficial and nice.
Yeah, thanks for that
Yeah.
insight, Shane.
What Shane's talking about is something called virtual Android. It's basically you can spin up a cloud software, cloud computer essentially at CMU that is, has all the software loaded on it that you need for these things.
That's incredible. I love it. Um, Thank you both for sharing that. That's great. We had a really good question. A lot of what we've been talking about tonight is civil engineering, but when we look at this particular program, would this be relevant for somebody in a different industry, such as manufacturing? That's a really great question.
Yeah, I can tell you that we have actually in our between the two different classes that we have right now, we have aerospace engineering, mechanical engineering, biomedical engineering. We have several folks who are really just general technologists, and are, just really interested in the 3D and simulation aspect without really an engineering degree. They're all thriving. They're all doing very well on the program. So I wouldn't say it's specifically civil engineering. A lot of the lessons are taught from the perspective of civil engineering, but one of my jobs is sort of the in-person is to help kind of take the general lessons and apply them more broadly. Most of what we teach is absolutely applicable to manufacturing, different engineering disciplines, and just, we are trying to teach it as generalist as possible, but within the domain of engineering.
Got it. Got it. That's really helpful. Thanks, Damon.
Yeah.
Um, And we had another question regarding somebody that's maybe planning to join a master's degree, and would this be a good first stepping stone into that pathway? I would personally say yes. These are fully accredited courses. My piece of advice, because I work with students in the same situation, is just make sure whatever program you have in mind, you clear that up with their department first to make sure our classes would be transferable into whatever that degree is. It's not like a universal credit or something that you can just apply anywhere. That would be my advice. But Damon, I'm not sure if you want to add something there too.
I mean, the only thing I'll add is these are, uh, credit-bearing courses. And so, they will show up on your transcripts. They would be applicable towards, some of these master's degrees. And when you look at kind of multiple certificates, there is discussion within the university and everything about thinking about towards sort of a stackable master's degree, type of a pathway, where if you take a couple of different certificates, it could stack towards that. That's still kind of in the works, but that is definitely something anybody taking the course now would be on a path towards one of those stackable degrees in the future.
Great, great. Thanks for sharing that, shedding some light there. We're getting some really good questions, so I'm going to keep rolling here. We had a very unique question with can a digital twin framework be adopted for developing regions such as island economies where infrastructure and connectivity might be limited? I think that's an interesting question.
Yeah, I mean, I think the specific implementation details, I would have to kind of dive more into that use case to kind of really understand it. But I mean, if, there's a lot of different ways you can look at a digital twin. It can be as simple as something that runs on a local computer right here, but does something very functional to simulate something in near real time and have that feedback loop with the users. That's the simplest digital twin case you can think of. And so if there's sort of an island economy type of problem or an island infrastructure or limited resources or limited connectivity, you can still do that. There's nothing stopping you from kind of building within that kind of environment and making it, absolutely something that can be leveraged for, infrastructure management, whatever you need. So yeah, I would definitely say it would be a very interesting use case.
Agreed. Agreed. Um, Excellent. Another question, just going onto the subject of interacting with CMU faculty, perhaps being more involved on real projects, especially those that may be falling within social or global impact. It's a good question.
I would absolutely say that there are opportunities to collaborate along those lines. Certainly, a lot of the coursework that we're doing is project based. And so, you could certainly use the projects that are both in the Principles to Digital Twins and in the Advanced Analytics course to kind of start testing out some of these ideas, working directly with faculty to kind of figure out what the best use cases are, what the tricky problems are, and how to start thinking about these through the context and the lens of digital twins. Shane, you were part of the earlier classes. We had different groups doing different projects. Do you want to kind of explain kind of some of the project work that was done and how that might be applicable here?
Yeah, in the first class that we took, I don't remember exactly how many people in the class, but we were able to divide us up into groups of two or three throughout the course, and that was a team that we had a team project that was due at the end, and we pretty much, me and the two other folks that were in the class with me on my team, we came up with whatever idea that we wanted to come up with to apply these principles to our project. I know the other couple teams that were there, they did the same thing. They brainstormed amongst themselves and came up with whatever that they wanted to do, and then to apply these principles that we were learning in that first class.
Yeah. And interestingly, digital twins, if anybody's kind of done video games, Unreal Engine, Unity 3D are kind of these 3D intensive physics-based simulation environments. And they kind of have a little bit of a foothold in the digital twin space. Unity 3D actually has a grant for, social impact type of digital twins effectively. We haven't integrated into the course, at this point, but, certainly there are overlaps, that could be part of the discussion in the class if there are class interest in those type of things.
Gotcha.
Yeah, I don't, and also like, I mean, there's a collaboration with the CMU professors, I mean, for sure, but I've also made contacts with the other folks out in the end, my other classmates, more or less. There are other civil engineers in there, there's aerospace engineers, mechanical engineers. So I've been able to talk with those folks about, how digital twins is used within their industries and projects they're working on as a way for me as a civil engineer to maybe take some of those ideas and put them into the civil engineering world.
Yeah, thanks for sharing that. A few of the students I worked with too that have taken or that are taking the program or taking the program, they really like that aspect of it. You could still make connections with your fellow classmates who are also in the same type of levels of work. So it's been a great way for that networking piece to come to fruition too. So thanks for sharing that. We did get a good question just about case studies. What do those look like? Are there projects that are affiliated with the program? Uh, Damon, if you want to talk a little bit more about that type of work.
Yeah, so as I mentioned, there are group projects in both the first class and the second class. In the first class, it's almost like a choose your own adventure type of thing. You have a lot of freedom on the use case that you're working with, but also through the first half of the project, we explore a number of different use cases, probably a dozen different ones in a dozen different fields to just kind of step through the different steps of digital twin implementation, just trying to apply to a large number of interests essentially. So you get a lot of different exposure to a lot of different ideas there. In the second class, the group project takes a little bit of a different form. We use a test rail that we have at the university. It's a scale model of a train, and students are able to run experimental test runs on it. And we have sensors on those train tracks, and we can, detect the stiffness of the tracks and whether there's defects. And so the group project on that one is largely about, staying within that domain perhaps, but being creative about how you solve different problems and how you ask the questions and frame the questions. So yeah, there's a lot of different case studies and use cases that are explored. It's, you know, I've seen a lot of broad interest throughout the class, and I try to kind of meet everybody where they're at.
And I could add to that as from a practical standpoint, the case studies that we've had, like in the principal portion of it, I mean, they were realistic. I mean, as far as what we were doing. I mean, I could, sit in class on a Tuesday night and go into work on Wednesday, and it's almost exactly, some of the things that we are talking about. And so far too, in the AI and predictive analytics course, the examples that we have in this course, I found examples out in, my job doing the same thing. I mean, they're maybe not exact, but the same type of architecture involved with them.
That's great. So you're just in this constant wheel of just uh, civil engineering all day, every day. Digital twins. That's
Yeah,
cool.
pretty much.
Yeah, yeah, yeah. You're fluent now. Yeah. Um, Great. And I think, Damon, you mentioned this. The next question was, would this be applicable to someone in a health-related research, precision medicine? I think you mentioned we have folks that are in biomedical engineering already, so I'm sure that might be applicable then.
Yeah, let me speak more to it. I mean, the answer is yes. There's absolutely application to these kind of ideas, and I'll say these ideas to precision medicine. The software is going to be different. The visualization is going to be different. The type of sensors that you might use are going to be different. But the idea of modeling dynamic systems and simulating the impacts and having some way of communicating that back to the user and putting together that diverse group of stakeholders that's going to kind of design this, develop this, and see this through both financially and logistically, those elements kind of remain the same. When I talked about kind of the biomedical, there's sort of an adjacency between biomedical and mechanical in many, many cases. Same with robotics and manufacturing. Those are all kind of adjacent to engineering effectively. And we kind of teach this digital twin as kind of a civil engineering slash mechanical engineering, joint type of domain effectively. So to the extent that it is kind of directly related to the engineering, there's sort of definitely a health related research piece. To the extent that it goes further to precision medicine and kind of gets down to the cellular level, the principles are still the same. You're still managing data, you're still managing, use cases, the people side of it, those are definitely still applicable, and those are very deeply covered in the fundamentals of the principles of digital twin class.
That's great. Thanks for sharing that. That's big.
Yeah.
All right, that was our last question in the chat. Um, Shane, this was a good question we got. Someone filled this out before the session. They're a little concerned about the time management balance piece, and they'd be curious to hear what a typical week looked like for you in the program as far as balancing this.
Well, one of the nice things about the course is it's divided into modules. So each week is a different module, and the online aspect of it is you can see the current week that you're in, and then you can also look forward to the future weeks to help your planning a little bit. And it's we have classes on Tuesday nights and Thursday nights for an hour, 8 to about 9. So that's the class time online dedication of it. But then the rest of it is really it's using the modules in the online version. The professors come up with videos that you can watch as you want to watch them. You can watch them 3 o'clock in the morning if you want. You can
Yeah.
rewind them and watch them again. There's also slide decks that professors have that you can review whenever you have time to review them. So it you're able to have a little bit of flexibility in your time management side of it, so you can do other stuff that you have. So a week is the Tuesday, Thursday class. Usually Monday, trying to get a handle on what's going on for that week. There's an assignment that's due on Sunday night, usually by midnight. So you spend that week, going through the principles of whatever that module is, with the assignment due by midnight on Sunday night. And with really the only, say, scheduled time you have is that Tuesday, Thursday portion of it.
Yeah. I would say probably the homework is probably one of the biggest time commitment. That's just a chunk you have to kind of reserve. And what I recommend to students is, come to class having seen the homework, because we scaffold it a little bit within those classes. If you can kind of do that and not wait until Friday or Saturday to open up the homework, you'll be a lot better off from a time management perspective.
Gotcha. That's Thank you both for your answers there. That was great. Yeah, I'm almost envious because I wish through my schooling that, during a lecture I had the ability to pause in real time and rewind, I was like, what did the professor just say? And then you're kind of just a lone wolf after the lecture to figure it out. And this is totally flipped, when it
Or even better, set it to 1.5x speed.
Yeah, there you go.
Watch
Yeah,
it.
speed it up. Speed it up. That's right. Yeah. So it's nice that there's that the way I like to say it's like there's agility within the coursework of how you like to learn, at what pace you like to learn. And a fantastic feature that we offer here. So yeah, thank you both for your answers there. Um, Getting some thank yous. You're welcome. Again, thank you all for attending tonight. This has been a really great session. Really good questions too. Um, if you all, we still technically have a little under 15 minutes. If you all have any other questions, this is the time. This is, you got two great answer keys here.
I mean,
Any,
if there's not, just to fill up, I
yeah.
really enjoy the courses that CMU is offering. I mean, from a student standpoint, from a professional standpoint, from a personal knowing the professor's standpoint. I mean, I really think that the courses are very well put together.
Yeah, thanks for sharing that. That's great. All right. Well, if we don't have any more questions, I guess we just did a great job. We just covered all of our bases here. Um, but Damon, Shane, thank you so much for attending tonight. Really appreciate it. So yeah, enjoy the rest of your night and thanks again.